Hello everyone. In this session, we are going to learn how you can do logging, debugging and monitoring of your .NET applications on AWS. My name is Srivan Tattanayaka and I'm a partner solution architect at Emerson Web Services. What's the agenda for today's session? We are going to learn why distributed or cloud debugging is different from traditional environment debugging. We are going to explore some login options available for .NET developers on AWS platform and how you can easily integrate your current existing login mechanisms with AWS. We will then look into how to integrate with Emerson CloudWatch events so that you can act upon different events happening on CloudWatch. We will finally dig deep into AWS X-Ray and then explore how you can integrate different .NET applications with X-Ray so that you can do distributed debugging very easily. So let's get started. The first thing to understand that there's a big difference between traditional environments and cloud environments. In cloud environments, the servers auto-scale. So they are not going to live for a long time. For example, during the morning peak time, you may have a server that will run for a few minutes to absorb that peak workload, and then they are going to die. So if you keep your login data or some important information about application performance or things related to application logs in the server, when the server dies, you are going to lose them. So you need to find some ways to bring these important information like performance data, your exceptions that happens in the application back into some central repository. And also you have, for example, imagine you are running a large set of containers on your environment. The nature of how they operate is once you want to run some task, you are going to run it with some containers, and after that the containers may die. So how can you track the events happening on those containers and then keep them in a secure central location so that you can access them later? So first thing you need to understand is that there's a big difference between traditional environments where the servers are running for a long time and you don't terminate them completely, and the cloud environments. The second thing is that remote debugging is good for development and test environments, but not for production. We .NET developers love to have remote debugging. But the thing is, it's not something that you can use in production environment with production data. So we need to find some clever ways how we can do this in production environment, and especially in cloud environments where you will have not only one server but thousands of servers. If you try to remote debug into a server or a server farm which auto scales, once you attach into a remote debugger, the server may die after a few minutes, or you will find it really difficult because the request may get routed not only to the server that you are trying to attach your Visual Studio, but maybe to another server. So that's why the remote debugging is not a good option for distributed check-in or distributed debugging. The final thing is that microservice debugging is a whole new thing. The reason why I'm saying that is, imagine that you have a set of microservices, and some of these services that you invoke may not be even .NET applications. So if you try to, for example, remote debug, you will not have an option, for example, to attach into the processors running. There may be some Java application, or it may be a remote endpoint that you invoke, maybe a service endpoint of another service provider. So you need to find some clever ways to debug these distributed systems where you have a lot of microservices. So let's get to the login section and then understand what are the options available for .NET developers to log into AWS platform. There are multiple ways. The options available for you depends, the option that you are going to select depends on what kind of use cases you have and how you want to modify your existing code base to integrate with AWS. The simple method is to write into Windows event logs. These Windows event logs have been there for a long time on Windows platforms. So you may use a code base like this where you use event log entries and then write some warnings, error messages to Windows event logs. So If your application also already using these kind of mechanisms, how can you get these entries back into AWS so that when the server dies, you still have these entries available in a central location? Let's say you have this application and you write into Windows event logs. So AWS has something called AWS CloudWatch agent, which runs on your Windows machine, and it can read these Windows event logs and then send them into a central repository called Amazon CloudWatch. Amazon CloudWatch is a place where all your diagnostic data are kept, and you can easily integrate it using this method for your .NET applications. The second approach is to use Windows performance counters. Let's say you have an application that writes some Windows performance count data into Windows performance counter log. So here you are capturing time series data. These performance counter data can be your custom counters, or they can be already existing counters like memory utilization. There are a lot of information that is already available. Things like, for example, how many times the garbage collector ran. You can capture data like how often you get cache hits in your memcache. So let's say you want to capture this data. Amazon CloudWatch agent can read these performance counters and then send them into Amazon CloudWatch. So that's another approach to capture some debug and login information into a central repository. Of course, you can use the typical login that you have been already using. Imagine that you are using some of these famous open source libraries. So you may be using nlog, which is a very famous login framework for .NET platform, or log4net, or Microsoft Enterprise Library. If you use any of these tools, and then imagine you are writing them into a log file in your server, Amazon CloudWatch agent can read this file and then send it into Amazon CloudWatch, and then keep them in a central repository. You can of course use CloudWatch API directly. You download a NuGet package, and with few entries, with few code, you can easily write different parameters into Amazon CloudWatch. So in this case, you don't go through in direct way to interact with CloudWatch. You directly write into Amazon CloudWatch. The fifth method is to use some custom log providers. For example, imagine that you are using some login library like nlog or log4net. They all expose some way to extend the existing login mechanism, something like iProvider, where you can log the details that you are writing using that API into an SQL server or a special XML format. So you can write your own provider that will interact with Amazon CloudWatch using Amazon CloudWatch .NET API, and then write them directly into Amazon CloudWatch. So in this way, you can control what kind of date time formats you want to have, what's the ordering that you want to write them. So all these things are under your control. Of course, if you are lazy to use existing log providers and then extend their interfaces, we have provided some NuGet packages that you can use to readily integrate with famous login libraries like nlog or log4net. And in this way, you don't need to write your own custom providers. You can directly interact with CloudWatch using these NuGet packages. Of course, Visual Studio Remote Debugger is still an option. So if you are planning to use Remote-Debugger, all what you need to do is to install the remote tools of Visual Studio. In this case, I'm installing for 2017. Do some configuration, telling what account that Remote-Debugger has to run, configure some securities, and then allow that Remote-Debug user to log in as a service, start the service. And after that, of course, you can attach Visual Studio into the processors running on these machines, provided that you have configured your firewalls, firewall rules, and security groups correctly. And the debugging experience is similar. You give your EC2 machine image, or your Elastic Beanstalk instance that is running, and you can attach to, for example, your IIS worker process. So this is some options, like if you are going to run your application on Amazon EC2 or Amazon AWS Elastic Beanstalk, you can easily do that. But in distributed environments, as I said before, this is not a good idea, because your request is going to be served by multiple applications, multiple running EC2 instances, or multiple running instance of your application, and you don't know to which application that you got the request. And also these servers are going to die maybe while you are debugging. If you don't want to have some of our APIs in your code base, you can of course wrap them with your own interfaces, and then you can use your interfaces instead of using Amazon provided interfaces. Let's go for a demo and then see how you can easily integrate different login mechanism you already have with Amazon services. This is a sample JSON documents that you use to configure AWS CloudWatch agent. Here I want to stream some custom log data, so I have specified it. I want to capture some Windows event logs. Here you can specify whether you want to capture information, errors, or you want to capture critical data. You then specify what Windows performance counters that you want to capture, the time interval. So it could be existing Windows performance counters or your custom Windows performance counters. The important thing to understand is that Windows performance counters is very powerful. You can even capture very detailed CLR level information. So if you just explore, I strongly recommend that you explore some of the performance counters available for you. Things like, for example, how many times the garbage collector ran. You can look for things like the number of threads running. You can generation to sizes of your garbage collector. You can look for things like cache hit ratios if you use memcache. If you are using ASP.NET, you can look for things like how many times the application pool restarted. So there are a lot of information available for you already on Windows performance counters. So the question is how you can get them back into CloudWatch. You configure this JSON document, and then the CloudWatch agent that runs behind the scene on your servers can send this data to AWS. A very common question that I get when I present this way of sending log data, Windows performance counters, exceptions to CloudWatch using CloudWatch agent is that what happens if the EC2 instance or the VM that you are running terminates as part of, let's say, scaling in activity? Will the CloudWatch agent have enough time to send the log files or the performance counters to CloudWatch? The answer is, in production environment, you design your systems in a way that the EC2 instances are not terminated immediately, but there's a small time gap, and during which the CloudWatch agent will have enough time to send it to the CloudWatch. Classic example is there are some events that you get before EC2 instance terminates, and you can make sure that the instance is terminated only when CloudWatch agent finish sending the data. So it could be, for example, when the auto scaling runs and the scaling in activity happens, you have some events that you can react and then send this log data. And once it sends this data, it will appear under logs. You can select the logs, so you can define any names or log groups if you want to categorize them. And when you select this, you can see that these logs appear. So this is a custom log that I have sent into CloudWatch. What I have done was I specified what's the location of that file. This is in this case C custom logs. And this is the text file. CloudWatch agent knows to send delta changes. so it's not going to send the full file always. So that's one way to capture your login information. If you want to, for example, capture Windows event logs, in this case I have captured them under system event logs, I can export them, for example, as XML documents. So I have like few in Windows event logs that I captured. So this may be coming from multiple servers. So here I have some Windows event logs that I have already captured. So let's try to search some of these Windows event logs and then try to locate the entries. So if you look at this event log entry, you can find that it has something called WMI performance adapter. So that's a text that I want to search. So imagine that this is an exception that you logged into Windows event logs. You can easily go into CloudWatch and then search for that entry. So if you have like millions of records, you can easily search it and narrow down your search to only the things that you are looking for, right? So that's an easy way that you can search CloudWatch entries and then find where the error happened. Of course, you can narrow it down based on the time that it happened. Another approach to do is to plot your data against some timeline, right? So if you want to capture time series data like Windows performance counters, you can use the matrices. So there are a lot of already existing values you can capture for different AWS services. In the case of Windows platform, if you want to capture performance counters, they will appear under a CW agent, which I have created here. So you can plot them against some graph. If you don't like that graph, there are multiple ways that you can create very compelling dashboards. There are a lot of partner solutions, for example, Splunk, that allows you to create stunning visuals out of the data that it gathers from CloudWatch. The CloudWatch itself allows some basic graphing and charting. But if you want to have, for example, maps and heat maps, there are a lot of partner solutions available. Shortly, I will showcase you how to integrate CloudWatch with one AWS service called Elasticsearch. So that's one way to chart your data along some time axis. Of course, you can integrate this one with S3 and then send this log data to S3, or you can stream this data to Amazon Elasticsearch service. Elasticsearch is, think it as a one big index. So what I'm going to do now is to showcase you how to integrate with Elasticsearch. So go to Elasticsearch. What you're going to do here is to create a Elasticsearch cluster that will maintain your index. Give it a name, what's the version you want to run, specify how much storage you are going to allocate, the network that you are going to run. Few configuration, it's not very complex. You just select few parameters, click next, 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 and you can create the Elasticsearch cluster very easily. Of course, you can define a very complex security. Usually you expose, if it is a development environment, to the network that the developers are accessing this. So in this case, I'm going to allow it to a certain network and not going to give very complex configuration. All right. Click confirm, and it takes about 5-6 minutes to create the cluster. So once the cluster is ready, you can go into that and then it will provide you a URL to log in into Kibana. So Kibana is an open source dashboarding tool that you can use to create stunning dashboards and visuals. So I log in into this Kibana. Right now, because I'm connected from my development network, it allows me to have access to that. So I can, because this is integrated with the Amazon Elasticsearch service, you can look for some indexes that the Elasticsearch service already has. So in this case, I have some index created for CloudWatch. So I select that index, and I'm going to create some data set out of it. So once you select this index, you want to tell what's the timestamp is going to be, and then go for the next step, and it will ask you to select the fields or the columns that you want to have in this data set. So It could be string, it could be numerical values. So if you want to take the average, of course, you can do it along a numerical value. So in this case, I'm capturing VPC flow logs that capture network traffic into my virtual private cloud. So the index is based out of that. And you have things like IP addresses, port numbers in this log. I'm going to create a nice dashboard out of it. So let's create a few visuals. I'm going to create a histogram. I'm not an expert in Kibana, so this visual is not going to be great. But I can select things like the x-axis, what's going to be the y-axis, how you are going to aggregate the information. So after a few entries, you can easily create a few charts out of it, right? So mind you, this is one option to create charts. So I created some histogram, not the greatest visual that you can think of. So once I create this visual, I can save it with a name, right? So if I go into saving, I can give it a name and then save that. So test some graph, save it. So once you create multiple visuals, you can create a dashboard out of it. So just create a dashboard. You can then add visuals that you have already created. In this case, the test graph that I have here, and then create a dashboard out of it. So you can use, for example, this one to create some dashboard that will represent your application performance, how many times the garbage collector ran, or plot it against your sales. So there are multiple options you can integrate with existing partner solutions. So far, we have studied different ways that you can stream data into Amazon CloudWatch. So they may be coming from direct API interaction, or maybe you are streaming your log data through some proxy like Amazon CloudWatch agent. So regardless how you send the data, those data is going to end up in CloudWatch. So that's one part of the story. The other part is that you want to act upon on this data. So for example, when you get an exception, you want to do something. When there's a security leak, you want to do something for that. Amazon CloudWatch is integrated with Amazon Lambda, and you can invoke a AWS Lambda function when certain events happens. And the beauty of that one is now you can reactively take some actions when certain events happens or when certain entries appear on CloudWatch. To give an example, let me showcase you an example use case. So in one of the companies that I worked before, we were creating some image rendering web service. So behind the scenes, we do some physics simulation, and it creates some body models which get directed into DirectX API, right? Microsoft DirectX rendering engine. There's a C++ CLI wrapper, and so the WCF for the Windows Communication Foundation endpoint communicates with the C++ CLI wrapper and gets some JPEG images that it renders to the website, right? There was a bug in this pipeline, which we found later is in one of the mistake that we have done in our DirectX coding, that we are not properly disposing certain buffers we have allocated, and that caused the images that are being rendered through this WCF service to be black images, right? So there was a bug in this system, but the challenge here was that we didn't have enough time to fix this bug because we were doing some production deployment. There was some major event that we planned to run this application. But one thing that we understood was that this issue happens only when we render about 40,000 images, right? So a quick fix that we gave for that one is when it renders about 35,000 images, we restart the service, right? So once you restart the service, the memory leak is gone because you need to again render about another 40,000 before it appears, right? It's a dirty fix, but it did the work we wanted to do until we find where the problem was. So in this kind of a situation, you can monitor, for example, how many times this service is invoked using CloudWatch. For example, you can integrate your load balancers with CloudWatch and then fire an alarm when you get certain number of requests. And then you can trigger a Lambda function to restart a service or restart the service that is leaking the memory. So a very simple approach that you can use to fix certain issues when you don't know where the problem is happening. Of course, you need to find a permanent solution once you identify where the problem is. Another good example is when you get exceptions, right? So this is a classic example. If you have been using or if you have been doing some ASP.NET development, this yellow page is very common one. So you can capture things like HTTP errors and then create CloudWatch alarms that you can fire to trigger a Lambda function that can do certain health checks or that can act upon in them and then, let's say, send an email. So there are different ways that you can integrate CloudWatch to reactively act upon to different events happening in your environment. Debugging microservices is a whole new challenge. Just imagine that you have an application that you have written in .NET that invokes some third-party services. So these third-party services may not even run .NET. They may run on Java and expose a REST API. If the third-party service, let's say, change their API and your application is no longer compatible with their new API, of course it's going to throw an error. So and how can you trace these errors if you are invoking a lot of services? Another good example is, let's say once in a while some of the service invocation times out because the third-party service or your own service times out. So how can you trace this once in a while situation that happens across millions of requests that you invoke or make to get some service out of a microservice? So there are a lot of challenges in tracing across multiple microservices, partly because they crosses your application boundaries and you don't have control over what the third party or your subordinate service provider is providing. So let's understand how you can easily debug this kind of an application using a service called AWS X-Ray. So AWS X-Ray is some tooling that we provide for .NET developers, especially, that you can easily integrate with existing applications. So we provide an SDK that you can use to trace across different service invocation. It helps you to capture exceptions, things like timeouts, and then visualize it in a way that you can easily pinpoint where the errors happens. Shortly, I'm going to give you a demo that will showcase the power of AWS X-Ray and then show you how you can easily integrate it with some applications. So how it works is you use our SDK to trace different requests that you use in your application, and then the X-Ray agent that is running on the machine or AWS Lambda or AWS Amazon Elastic Beanstalk capture these traces and then send it to a central location. And based on a traced ID, it can then combine these different traces coming from your application or from another third-party application into one trace log, so that you can easily find what happened, when it happens, what are the exceptions being thrown, what are the latencies, how long it took to invoke a service, and then summarize it in a way that you can easily visualize it and then pinpoint where the error happens. So let's go for a demo and then see how this works. So this demo is based on a simple application called My Octopus application. So it's written in ASP.NET MVC Core. It has a web API. And because it's a ASP.NET Core application, of course, you can run it on AWS Lambda, or you can run it on AWS Elastic Beanstalk, which is our managed version of IIS web services, which you can host this application. So how this works is I have this ASP.NET application. In this case, of course, I'm going to run it on AWS Lambda function, and it's going to invoke some control actions. So I have integrated with Amazon API Gateway, where I expose this website using an API endpoint. And so this API endpoint, when I invokes it, this application invokes Amazon S3 bucket API to list the buckets that I have in my account. And it also invokes Amazon SQS or simple queuing services to list down the queues or list down the queue names and then show it. This is a simple microservice that invokes two AWS services. So let's see how this works and how you can use X-Ray to debug this application. I'm in my Visual Studio. I have created a very simple ASP.NET MVC core web application. You can find that I have added a few dependencies, so they all come as Nuket packages. I added some references for X-Ray Nuket packages. If I run this, it runs as a normal IIS website. Of course, you can deploy into Elastic Beanstalk or to AWS Lambda, right? A simple IIS website that I created. So let's see how I have integrated X-Ray tracing into this application. So let's stop this application. And if you go into the pages, let's go into first the startup class. You can find that at the startup, I have mentioned that I want to trace all the requests that is going for SQS and S3. Right? So that's one way to tell X-Ray that you need to trace all this information. Alternatively, if you want to trace all the AWS services, you can say register X-Ray for all AWS services like this. Right? So I'm tracing all the invocation of AWS services. I can inject interfaces as a dependent injection. So this is what I'm doing here. So if you are using a framework like Unity, you can also do that. So in the logger, I have an extension method here, and I'm going to call it logger add lambda logger. All the other cloud service providers also integrate their login mechanism in a method like that. So we use the same methods that Microsoft provides, or extension points that Microsoft provides, to add extensions into X-Ray. So here I'm tracing, because I'm going to run this on a Lambda function, I'm going to trace it at this Lambda logger. And this is where the root is defined. So I mention it as my Octopus app. So it knows the invocation comes from my Octopus app. So in the service template, you can find that I have enabled the tracing as active, so that it will enable the tracings once I deploy this one into Lambda function. All right. So let's go into, of course, I can deploy this one into AWS Elastic Beanstalk. This is yet another IIS website, but in this case, I'm going to publish into AWS Lambda. You can do it from your Visual Studio itself, or if you have a CI/CD pipeline, you can do it with some command lines. So you specify what's the profile you are going to use, to which region you are going to publish, and what .NET framework that you are going to use, and then click publish. So it will zip it up and then publish it to AWS Lambda. So after a while, the Lambda publication will finish. Because I have already published this website, you can find that it's an upgrade in progress instead of create. And after a while, the upgrade will succeed. So update is completed now, and it gives a URL that I can invoke. So let's go into our console and then find where this is created. This website has an API endpoint. So if I go into Amazon API Gateway, you can find that there's an endpoint called My Octopus App, and it has a few stages, one for production and one for staging. So I'm going for the production endpoint and copy that URL. Copy this URL, and I'm going to open that URL in a browser. So like before that you saw this website running on your local machine on local IIS. So this is now running in a serverless environment, and you get the same experience. So what I'm going to do now is to invoke a help controller called helper. You can find that I'm injecting my dependencies, in this case API interfaces to invoke Amazon S3 and Amazon SQS. So all our APIs are exposed as interfaces. So if you want to mock them for unit testing, you can easily do that. So I'm invoking a few AWS services, list bucket and list queues. So when I invoke that, it's invoking some different services where it represents or simulate an invocation of a microservice. So I'm also writing certain parameters into console. Because I have enabled Lambda logger, all these console write lines are also traced and they will appear in my CloudWatch. So this is the configuration I have given. So let's go into that view, the help view, where it invokes the method. So all what it's doing is printing this list of S3 buckets I have into the HTTP page. So this is the X-ray view that showcases you, hey, I start my Octopus app and it invokes two services, SQS and S3. So I can drill down into this invocation and then see what happens. So if there are any errors, it will showcase you. In this case, there's no any errors. And if I go into this trace, you can find that the start where I mention app views X-ray, my Octopus app, and that's where the root of this trace comes from. And then it's invoked two services, S3 and SQS. You can find the API endpoints that invoked. So for example, if SQS timeout, you can find some errors happen there. So if I go into my Lambda function, I can view traces from there also. When I publish this, it got published under a function called my Octopus app. So if I go into that Lambda function, you can do some monitoring. So here it gives an idea around how this Lambda function is invoked. In this case, it's through API gateway. But if you go into the monitoring section of your Lambda function, you can find things like how many times this Lambda function is invoked. And also you can go to the logs to capture things like console write line. So here I'm going into the log that Lambda function created. And you can find that there are a few entries that it has added. So let's see where this hello guys entry actually came from, right? So everything that you write to the console or everything that you explicitly write to CloudWatch will appear here. So if I go into my code base and then look where this entry called hello guys came from, you can find it, I guess, in the index where it appears. So you can find that I'm doing a console write line called hello guys, and that's why it ended up in the CloudWatch. So in this way, you can easily trace any errors that you have. You can capture exceptions if you like. If there are any errors, there are special API endpoints provided for you to capture exception and log them directly. So here, if I go into this, you can find that the different, how long each invocation took. And you can easily pinpoint some bad behaving invocations. For example, if one of the service takes too long to invoke, you can trace where that problem happened. X-ray provides some ways to filter the entries that you find in its console. For example, here I'm applying a filter condition to filter the URLs that I'm interested in. Here you can clearly find that there are few invocations in the trace lists that shows about 13-second latency, which is clearly unacceptable. So if that's the case, if it takes about 13 seconds to do this remote sign up, seems like there's an issue with that. So what you can do is now to go into detail and then explore where this problem happens. You can clearly see that when you dig deep into that trace entry, that the Amazon DynamoDB invocation took about 12.9 seconds. And it's a put item request, and maybe there's something bad happening when you try to do some put items. So if you go into some more detail around this, why this happened, you can even trace further. Here, once you go into the segment, you can find that when you invoke this put item, it has retried the put item invocation for about 9 times. Seems like there's something wrong is happening in this application, and you can easily trace where it is happening. So do apply some filtering again for HTTP status 409 where the conflict happens, and you can find that there are several entries that you can see with 409 trace, right? So if you go dig deep into that, you can clearly see that with the mark that it gives you with the orange exclamation mark, that's for these API endpoints something bad is happening, and you get the 409 no HTTP conflicts errors. So if you go deep into that, you can find where that exception is happening. And of course, if you use C# API, if it is a .NET application, you can find in which line that it happened, and you can easily pinpoint where the problems are happening. So far we learned about X-ray and how you can use it to debug distributed application. Hope you enjoyed the session. You learn about how you can easily integrate your existing login mechanism that you use in your .NET applications with AWS, how you can do distributed debugging, how you can easily use CloudWatch integrated debugging techniques to check and debug complex applications that you may write in your environments. Thank you.